Hey guys, so we are getting ready to take our test over Unit 7, which is Quadratic Functions, tomorrow. So a big part of the test is going to be over just identifying key features. So let's look at number 1. All of the key features that you need to be able to identify are these that are listed below. So zeros is super important. So that one goes by a few different words. I just want to write down to the side. So if you remember this acronym, ROCKS, it stands for what zeros is. So R is for roots. That O is not really an O, it's a zero. So it stands for zeros. Then the X means X-intercepts. And then the S is solution. So all four of those words mean the same thing. So I know it says zeros, but really what they're asking you, like in literal sense, is the X-intercept. So looking at this graph, here's our X-axis. You're going to look to see where it crosses. So from where I'm seeing, it crosses at 2 points. So this one has 2 zeros. It has one at -4. So -4, 0. That's how you would write it as a point. And another one at +2, 0. Okay, the next thing up is Y-intercept. So this one's a lot more literal. So Y, look for the Y-axis. And then just follow it, look to see where it crosses. And looks to me like it's crossing at -8. So writing that as a coordinate would be 0, -8. Okay, axis of symmetry. That's a vertical line, an imaginary line. So where would you have to draw this if you wanted to cut this parabola in half? So look for the vertex, look for that bottom point. And that's where you're going to draw your vertical line. So I'm just doing mine with dashes. And if you take a look at that, each side of that vertical line is exactly the same. So for axis of symmetry, it's going through the -1, it's touching the -1, and that's on the x-axis. So you would write this as x equals -1. Okay, so that axis of symmetry will always go through your vertex or your minimum or maximum. On this case, it is a minimum because it is pointing up. So this is our low point. So as a minimum. And the value, you always look at the y value. So it's at -9. Vertex, all you would have to do is put the axis of symmetry and the minimum together. So -1, -9, or you could just look at your graph, -1, -9. Okay, domain and range. Domain, as long as it has arrows on both sides, is always going to be all real numbers. But range is not that easy, because sure, the arrows point up forever, but there's definitely a bottom. Like we said, it has a minimum. So we need a way of saying that the graph is everything above that -9. So y, and then we have our -9. But if we want everything above that, that's going to be greater than or equal to. Okay, so all of this information you need to be able to get just by looking at the graph. Okay, so let's do one more for practice. So let's start with zeros. So in this case, so 0 means x-intercept. There looks to be only one 0, which can sometimes happen, and that 0 is at 4. So we're going to write 4, 0. Y-intercept, so y-axis, look to see where it crosses. It's crossing at -8, so 0, -8. Axis of symmetry would be where we can cut this in half. So it looks about right there. So the left side and the right side are the same of that dotted line. So that's going to be x equals 4. This time our parabola is pointing down. It's upside down. So it has a maximum value. You follow it over to the y. So it's at 0, a maximum of 0. Our vertex just happens to be the same as our 0. and it's at 4, 0. Domain, again, because it has arrows, should be at all real numbers. And range always starts with a Y, but this time, since it's pointing down, you want everything below that maximum. So everything below 0, which would be less than or equal to 0. Okay, our next section that we need to do is transformations. So before we even look at those questions, there's a little kind of template that I want to show you, which is Vertex Form. Vertex Form is y equals a parentheses x minus h squared plus k. So just by looking at that, you should be able to tell a few things. So first of all, it's called vertex form because h and k represent the vertex. That'll also tell you how much it shifts left and right, up or down. So h, if it is minus h, it is going to go to the right, so that direction. If it is plus h, it is going to go to the left. Then k controls up and down. So if it is plus k, that's going to go up. Minus k would go down. So the one that I skipped in the very front is a. So a does actually a bunch of things. If a happens to be negative, so negative a, that would be a reflection over the x-axis. But otherwise, it should be a number. If that number in that spot is greater than 1, that is going to be a vertical stretch. If it is less than 1, it's going to be a compression. Okay, so if you know that basic template, if you know vertex form, then transformations should come pretty easily. So let's look at that very first one. So number 3 says the graph of f of x equals x squared is reflected, so there's that word reflected, over the x-axis. So I know that there's going to be a negative sign. And it is shifted up 7 units. So looking at vertex form, I know that k is the one that controls up and down. So there's going to be a plus 7 here at the end. Then because it's reflecting, there's going to be a negative sign in this spot. But it's not moving left or right, so there's not going to be any h, which means that there's no need to put any kind of parentheses. So the equation for g of x will be negative, because of that reflection, x squared, I don't need parentheses because it's not moving left or right, but then plus 7 because it is moving up. If you want to check your answer, you can graph the original and then graph the second one and just double check that it does the 2 transformations it says it should. Okay, let's look at our next one. The graph of f of x equals x squared is transformed to create g of x equals x minus 4 plus 1. List the transformations. So those 2 numbers, that's the vertex of that new graph. So starting with the 4, so it's going to shift 4, but it's inside parentheses, which means that it's horizontal. It's a minus sign, so that means that it's going to go to the right. Then the 1 is on the outside, so that means it's vertical, but plus means that it's going up. So those are the 2 transformations just based off the equation. Okay, so for this third one, This is not going to be quadratic, it's actually going to be linear, so it's a little different than what we've been doing in class. So this one I actually do want to show you on the calculator. So let me move this around a little so we can make some space. Okay, to see a graph of these two functions, we're of course going to want to pull up a graph page. You can click on this second icon for graph, or what I like better is to go to 1 for new document and then 2 for add graph. The first graph says f of x equals x. So we already have f of x equals, we only need to type in the x and press enter. Okay, the other function they gave us is g of x equals 2f of x plus 3. So we're going to have to use this f that we have here. So we're going to go ahead and press tab. I know this is not a g, but we're going to pretend this is g. There's already an equal sign. So we're going to start with 2. Afterwards, it has an f. But if you just type in f, it looks like a normal letter. You have to put f1. That way it knows that you're talking about the previous function. And then continue the rest, parentheses x plus 3. And then enter. So we've been looking at transformations of quadratics, and these are not quadratics, they're lines. But a lot of the same rules still apply. So for instance, let's start with the 2 in the very front. So we know when there's a number in the front of the function, that is a vertical stretch. So look at this blue one, this is the original, and look at the slope of this line. Like it's just going up 1 over 1, up 1 over 1, up 1 over 1. But then when you look at the red one, it would have to go up 2, then over 1, up 2, then over 1, up 2 over 1. So that makes this red line, which remember this would have been G is steeper than F. So whichever one has the bigger number in front is always going to be steeper. If this had been a fraction, then it would have been less steep. So whole number makes it steeper than the original. The other thing, so this plus 3 on the inside, again, just knowing from our transformation rules, that means that it's going to have a horizontal shift. A plus sign, you have to think of it opposite of what normally means that you're going to move to the left. So see right here, it went through the center, the original blue one. But if you go to the left 3, 1, 2, 3, there's our red line. So it went 3 to the left. And what I'm pointing at specifically is their x-intercept. So the x-intercept moved 3 to the left. Okay, so from that video, the transformations that it talked about is that the red line is steeper than the blue one, and the red one represented the G. So G is steeper than F. So that was one thing. Second thing is the red one is on the left side. So G is specifically 3 units to the left of F. And if you look at their x-intercept, that's really what we're looking at here. So x-intercept of G is 3 units left. So with this kind of question, your best bet is going to be to graph it. Okay, now let's look at the one next to it. Okay, this one says the graph of f of x equals x squared is transformed to create the graph of g of x. List the transformations. So this time we're looking at a picture. F of x is that blue one that is dotted. So I'm going to color code. I'm going to highlight that blue. And I can tell it's F because it has a little tiny F next to it. And g of x is the red one. Same thing because there's a little g next to it. So that's how I know. So one of the main differences that I see is that it's upside down. So if it's upside down, that's going to be a reflection. Over the x-axis. Next thing I see is it should be at the origin, but the vertex is way up here. So it moved 1, 2, 3, 4, 4 to the left. So it went this direction. And then it goes up by how much? That is 1, 2, 3, 4, 5, 6. So 6 up. So that vertex is at -4, 6. Okay, so just by knowing those transformations, it's pretty easy to write an equation. I know it doesn't say to, but g of x would be negative x plus 4 squared and then plus 6. Okay, our next topic, so turn to the back of your page, is writing equations for quadratic functions. So one way to write a quadratic function is to remember what vertex form is. So I'm going to write vertex form right up here. So that's vertex form, where HK, that's the vertex. So this question says, which quadratic function in vertex form can be represented by the graph that has a vertex at 5, -3, so there's our H and K, and passes through the point 7, -1. So if I'm looking at vertex form, I can fill in HK, so I'm just going to put y equals a, x minus, so it has to be minus sign, h is 5, squared, then plus k, but since k is negative, I'm going to put -3. So we're very, very close. The only thing is that we should never leave it just a. We should actually figure out what that is. So in order to figure out what that's going to be, that's where the other point comes in. We're going to use that for x and y. So -1 equals a, 7 minus 5 squared minus 3. And now let's solve for a. I know that 7 minus 5 is 2. Then 2 to the second power is 4. Let's add 3 to both sides. So that gives me 2 equals 4a. And then divide by 4. So a equals 1/2. So back to this one here. This one I wrote in green. All I have to do is replace that a with a 1/2. So my real actual equation should be y equals 1/2 x minus 5 squared minus 3. Remember that tomorrow's test is going to be multiple choice. So one thing that you can do is graph your answer choices and then Control T for table and just double check that it goes through both of these points. Okay, our next one says, what quadratic function best models the data in the given table? So if you look at that, it has a lot of decimals in it. So more than likely our equation is going to have decimals in it as well. So we're going to write this in standard form for a quadratic, not vertex form. So that's y equals a, x to the second power, plus bx plus c. So we need to find numbers to fill in for a, b, and c. And the way you do that is by using your calculator. You are going to do quadratic regression. So same as we did before, let's make some room. And I'm going to show you how to do that on the calculator. Okay, to type in a table into your calculator, you can go to this fourth little icon that has like a spreadsheet on it, or you can go to 1 for new document, and then 4 for add lists and spreadsheet. Okay, so you want it to look like the table, so you're going to move up here to where that 8 box is, and type in an X, enter, and then over where the B box is, type in a Y. So that's the title for our table. Do not type in anything in this one. You're going to want to start typing where the 1 is at. So let's start typing in all of our X values. So there's our X values. And now let's go back and type in all of our Y values. Make sure that you're typing them next to the correct X. Okay, so there's all of my values typed in. Okay, so now from here, we are going to go to Menu, then 4 for Statistics, 1 for Stat Calculations, and then 6 for Quadratic Regression. So remember, these are the same steps for any kind of table. It's just that right now we're specifically dealing with quadratic. That's how I know to pick 6. When you click enter, this is going to come up. So X list just means where did you type in all your X values? Well, we titled that column X. And then for Y list, we titled that column Y. Once you have those two things typed in, you can click enter. I think you need to click it twice. And then all of your information shows up. So our equation for a quadratic equation, just for standard form, is y equals ax squared plus bx plus c. But now I know that a is 1.5, b is negative 2.25, and c is 7. So all I have to do is go and plug in those 3 numbers where they go in standard form. All right, so now that I have those 3 numbers using my quadratic regression, I can go back and say that the equation that matches this table is y equals 1.5 x squared. I'm using a from right here. Then b is negative 2.25, so minus 2.25 x. And then plus c, and c is 7, so plus 7. That is the equation that goes with the table. Okay, our last section is on solving quadratic equations, solving quadratic functions. So remember again what we talked about on the front of the page, that acronym ROCKS. So that's roots, zeros, x-intercepts, and solutions. So if it's saying what are the solutions, that's just another way of saying what are the x-intercepts, what are the zeros. So the easiest way to do this is by graphing. So that's what we're going to do for this one. Let's graph. Since we know that solutions means the same thing as roots, zeros, or x-intercept, the fastest way to solve a quadratic is by graphing. So I'm going to go ahead and go to a graph. And as long as your equation equals 0, you could type it in the way you see. So 4x squared plus 11x minus 3. I know it has equals 0, only we're not going to type that part because we already have an equal sign, so it doesn't make sense to have 2 equals. So just like that and press enter. So there is our parabola that represents this quadratic equation. Our zeros, our x-intercepts, those are the solutions. So we just got to find out where it's crossing. This one looks like it's a whole number, so it'd be pretty easy to count. But this other one is not so easy to count. So the best way to do this is menu, 5 for trace, and then 1 for graph trace. So menu 5, 1. Press enter, and it gives you that cursor. So you're going to use that cursor to move left and right. So I'm going to do the one on the left first. So I'm just going to go all the way. When you see that little yellow label pop up that says 0, let me do that again. So see, it's right there. That's how you know that that is the solution, because remember, 0 is the same thing as solution. So when that yellow flag pops up, you're going to look at the bottom corner. So that first solution is negative 3. Now we're going to move over to the one on the right. So I'm going to use my right arrow until I am on top of it, and that little yellow flag that says 0 pops up. So there it is, it says 0. So bottom right corner, that other 0 is 0.25. All right, so based on the graph, we know our 2 solutions. Our 2 solutions are x equals negative 3 and positive 0.25. The next one, we're going to do exactly the same way. Only problem is it does not equal 0. You need it to equal 0 first. So you always do the opposite. Since they're both positive, you're going to subtract them both. That way they can cancel. So that's going to make our equation look like 2x squared minus x minus 15 equals 0. And now it's ready for you to type it into the calculator. Okay, for this second equation, we're going to do the exact same thing that as we just did. I don't want to erase this because I feel like it's just going to be two things on top of each other. So I'm going to go back to the home screen by pressing on, and then I'm going to press the add graph again. So it's just going to open another graph for me in a second tab. So remember that you have to set the equation equal to 0, and right now it doesn't. So always leave the x squared where it's at. So I'm going to leave 2x squared exactly the way it is. But the other two things, we need to move them over. Since it's a positive x, when you move it over, it's going to be negative, so minus x. And then again with the positive 15, when you move it over, it becomes negative, so minus 15. Then just press enter. There's our new graph. So just like before, one of them is kind of in between, so this one's not easy to count, and one of them's a whole number. But let's find them exactly. So menu, 5 for trace, and then 1 for graph trace. The cursor automatically goes to your Y-intercept, so I'm just going to go to the left and find the left solution first. Remember, 0 is the same thing as solution, so as long as that yellow flag shows up that says 0, your bottom left corner, that's one of your solutions, negative 2.5. Now let's move to the right. Until that flag that says 0 pops up. And now look at the bottom corner. The other solution is at positive 3. Okay, so that function has solutions at negative 2.5 and positive 3. Okay, and that is it for our review. Please make sure that you fill out the review and you answer all the questions in this video, and let me know if you have any questions over anything.